So let's explore the meaning of this inverse demand function. So if we remember, when we have an interior solution, remember, if an interior solution, and we rule out kinky preferences, so we ruled out those kind of right angles or the kinks right at the optimal choices. Then we had this MRS condition, and the absolute value of the marginal rate of substitution equal that price ratio. So at the optimal level, of good one, X1 star, P1 equals this absolute value of MRS times P2. So at X1 star, or whatever you want to label, the optimal amount, the optimal decision, given these prices and your income. And so what's happening here is that the price of good one is proportional to the absolute value of the marginal rate of substitution and the price of good two. So at X1 star, price of good one is proportional to the absolute value of good two. Sorry, the absolute value of MRS between goods 1 and 2. So in particular, I mean, we're holding P2 as some constants, it's some price, right? We're holding that constant. And so the price of good one is proportional to this marginal rate of substitution between the two goods. And if we kind of set P2 equals 1, we can kind of simplify it a bit more. So let's erase this board and talk about what happens if we set P2 equals 1. And then now the price of good one is exactly the marginal rate of substitution. And that's going to have a particular meaning. So we just said that P1 equals the absolute value, the marginal rate of substitution times P2. And let's set P2 equals $1, and P1 just equals the absolute value of the marginal rate of substitution. Well, what is the marginal rate of substitution? It's the rate at which you're willing to give up one good for another, right? Then at X1 star, so the optimal choice of good one, the price of good one, that's the price of good one, is telling us how much the consumer is willing to give up good two to get a little bit more of good one. Which is just like this is the definition of a marginal rate of substitution. How much you're willing to give up of good two to get a little bit more of good one. And so now let's think about, well, what if good two is money that we're spending on other goods? Let's say good two, money spent on other goods. So anything else but good one. And then let's erase this and kind of talk about what the meaning is when good two is that kind of, that good, that composite good of everything else. And good one is something that we're interested in. So I just rewrote that up here. So good two, and we're imagining good two is the dollar spent on other goods. And if you remember that situation, the MRS can be interpreted as willingness to pay. Willingness to pay. So in this case, if P2 equals $1, then the price of good one, which we're labeling P1, measures the marginal willingness to pay for good one. Oops, for good one. Right, because then again we have P1 equals the absolute value of the MRS, since P2 equals $1. All right, so now let's go back and get this. We kind of got down to this idea. Now we need to step back and kind of think about what this means for the inverse demand function as a whole. So what this means is that at each quantity x1, the inverse demand function measures the dollars the consumer is willing to pay for a bit more of good one. So for like the last unit basically, right? I mean technically it's gonna be the last unit of good one. So when x1 is small, the consumer is willing to pay a lot, or give up a lot, for a little of good one. And that's going to decrease as amount of good one increases. So that was, I'll draw like a tiny little diagram here, but we have this inverse demand function like this. So with low levels of x1, they're willing to pay a lot for a little bit more of x1. And as, a little bit more good one. x1 is the amount of good one. But then as we increase the amount of good one, as we move along this axis, their willingness to pay is going down. So that gives us like a nice interpretation of what this inverse demand function is really capturing.